The AGM-114 Hellfire missile is one of the most recognized precision-guided weapons in the world, primarily associated with modern attack helicopters, unmanned aerial vehicles, UAVs, and various fixed-wing and ground-launched platforms. Over the last 4 decades, the Hellfire family of missiles has become a cornerstone of tactical strike capability for many military forces, especially the United States and its allies. Its combination of accuracy, reliability, and versatility has made it indispensable in counterterrorism operations, armored warfare, and precision engagements in complex terrain. Although often discussed in the context of drones or helicopters, the Hellfire's evolution spans numerous technological advances and strategic shifts. Understanding the missile requires exploring its history, design philosophy, guidance systems, operational use, and the different variants developed over time. Historical background. The Hellfire missile program began during the 1970s when the U.S. Army sought a dedicated anti-tank weapon that could deal with modern armored threats. During the Cold War, the possibility of large-scale tank battles in Europe encouraged the development of weapons that could quickly disable armored vehicles at long range. Initially called Heliborne Laser Fire and Forget, the system later became known as Hellfire, although the name is technically an acronym rather than a reference to destructive power. The missile entered service in the 1980s, notably integrated onto the AH-64 Apache attack helicopter. Its laser-guided system allowed pilots or ground designators to illuminate a target with a laser, which the missile would then follow with high precision. This gave the Hellfire a strong advantage over earlier unguided rockets or wire-guided anti-tank systems, enabling engagements from greater distances and with improved accuracy. Over the decades, the Hellfire evolved significantly, expanding far beyond its original anti-tank role. Conflicts such as Operation Desert Storm, the War on Terror, and various peace support missions accelerated its adaptation, leading to multiple variants optimized for different targets, from armored vehicles to bunkers, small boats, and even moving personnel. Design philosophy and general characteristics. The Hellfire missile is known for being a precision-guided, air-to-surface weapon characterized by compact size, versatility, and modular design. While exact performance specifications vary slightly among different variants, the missile generally measures around 163 centimeters in length and weighs approximately 45 to 50 kilograms. Its relatively small size and weight make it suitable for a wide range of platforms. Modular construction. One of the key strengths of the Hellfire design is its modular architecture. This allows different warheads, guidance systems, and propulsion components to be integrated without redesigning the entire missile. As threats evolved and new operational demands emerged, engineers could update individual parts of the missile to improve performance or adapt to new mission types. Target engagement philosophy. Hellfire missiles are engineered to engage targets with precision in a variety of conditions. They are capable of being launched from low altitudes, in adverse weather, against moving targets, from platforms in motion. Its ability to home in on precise target points reduces collateral damage and improves effectiveness in urban and sensitive environments, which is essential in modern counterinsurgency operations. Guidance systems. Throughout its evolutionary timeline, the Hellfire family has relied on several different guidance mechanisms, each suited to specific mission requirements. 1. Semi-active laser guidance. SAL. The earliest Hellfire variants use semi-active laser homing, where a laser designator, either on the launching aircraft, another aircraft, or ground forces, illuminates the target. The missile's seeker detects the reflected laser energy and adjusts its flight to strike the target accurately. This form of guidance makes the missile extremely precise but requires the target to remain illuminated throughout its flight. It also allows collaborative operations, where one platform marks a target while another fires the missile. 2. Millimeter wave radar (mmW) guidance. Later variants, such as the AGM-114L, Longbow Hellfire, incorporate millimeter wave radar seekers. This gives the missile true fire and forget capability, meaning the pilot can launch the missile and immediately maneuver or change targets without maintaining illumination. Radar guidance improves performance in conditions where lasers are less effective, such as heavy smoke, dust, fog, battlefield obscurance. It is particularly useful against armored formations in fast-moving, high-intensity combat scenarios. 3. Combined guidance. Some variant families integrate hybrid guidance modes, allowing flexibility depending on mission conditions. This adaptability is one of the reasons the Hellfire remains relevant decades after its introduction. Warhead types and mission roles. The Hellfire family includes multiple warhead types, each designed to address different tactical challenges. 1. Anti-armor warheads. Originally designed to defeat tanks, Hellfire's anti-armor versions use shaped charge warheads that focus explosive energy into a jet capable of penetrating heavy armor. These versions proved their effectiveness during armored engagements in the Middle East and other regions. 2. Blast fragmentation warheads. As military operations shifted toward urban warfare and counterinsurgency, the need for weapons effective against personnel, light vehicles, and structures increased. Blast fragmentation warheads were introduced to expand the Hellfire's utility beyond tank destruction. 3. Thermobaric warheads. For hardened or enclosed structures like caves, bunkers, and buildings, thermobaric warheads provide enhanced internal blast effects. These variants have been used in operations against fortified enemy positions. 4. Anti-ship maritime warheads. Certain variants are optimized for small naval targets such as patrol boats, pirates' vessels, and fast attack craft. Maritime operations benefit from the missile's ability to target moving objects with high accuracy. Launch platforms. The Hellfire missile's versatility is amplified by the wide array of platforms that can deploy it. 1. Attack helicopters. The missile's most iconic pairing is with the AH-64 Apache, which can carry up to 16 Hellfire missiles. Other helicopters capable of using Hellfire include Ohio 58, Kiowa, MH-60 Seahawk, A-1 Cobra Viper. Various international attack helicopter fleets. 2. Unmanned aerial vehicles, UAVs. In the 2000s, the Hellfire became synonymous with armed drones. Platforms such as the MQ-1 Predator and later MQ-9 Reaper rely heavily on Hellfire missiles for precision strikes. This UAV missile combination transformed modern warfare by enabling long-endurance surveillance, low collateral damage strikes, engagements in remote or hostile areas. 3. Fixed-wing aircraft. Some light aircraft and special operations platforms carry Hellfire missiles for precision strike missions. 4. Ground and naval launchers. Ground vehicles and naval ships can also employ Hellfire launchers, enhancing flexibility for defense forces operating in various terrains. Operational use and global impact. The Hellfire missile has played a major role in multiple conflicts, especially from the 1990s onward. Its effectiveness, precision, and relative low collateral damage made it the weapon of choice in many targeted operations. Counter-terrorism and counter-insurgency. The missile's precision has been crucial in engagements requiring minimal collateral damage, such as eliminating high-value targets, destroying enemy positions in populated areas, neutralizing lightly armored vehicles, supporting ground troops in close quarters. Conventional warfare. In high-intensity conflicts, the Hellfire's anti-tank capabilities and radar-guided variants have demonstrated strong performance against entrenched or armored targets. Variants of the Hellfire family. There are over a dozen variants of the AGM-114, each optimized for different missions. Some notable ones include AGM-114A-B-C, early laser-guided anti-armor models. AGM-114K, improved cell guidance with multi-purpose warheads. AGM-114L, longbow Hellfire, radar-guided fire and forget. AGM-114M, blast fragmentation variant. AGM-114N, thermobaric version. AGM-114R, Romeo, multi-purpose variant capable of engaging various targets with a single missile design. The Romeo missile became one of the most widely used versions due to its ability to handle multiple roles, armor, structures, personnel, and moving targets, using an advanced multi-purpose warhead. Advantages of the Hellfire system. Several features contribute to the Hellfire's longevity and widespread adoption. 1. Precision and accuracy. Laser and radar guidance offer high hit probability, reducing the number of missiles required to neutralize a target. 2. Platform versatility. Helicopters, drones, ground vehicles, aircraft, and naval platforms can all deploy Hellfire missiles. 3. Adaptability across missions. With multiple warhead and guidance options, the missile is effective against a wide spectrum of targets. 4. Reduced collateral damage. Precision targeting allows military forces to minimize unintended damage in sensitive environments. 5. Proven combat record. Decades of operational use in diverse environments have demonstrated the system's reliability. Transition to the future. JAGM. Although the Hellfire remains in service, it is gradually being replaced by the Joint Air-to-Ground Missile JAGM, which blends advanced multi-mode guidance, including laser, radar, and infrared, into a single missile. However, due to its proven capability, the Hellfire is expected to stay operational for many years. Conclusion. The AGM-114 Hellfire missile stands as one of the most impactful precision-guided weapons in modern military history. Its evolution from a Cold War anti-tank missile to a highly adaptable, multi-role strike weapon reflects both technological progress and changing warfare requirements. With its precise guidance, varied warhead options, and compatibility with numerous platforms, especially UAVs and attack helicopters, the Hellfire has shaped tactical operations for more than 40 years. Even as newer systems like JAGM emerge, the Hellfire remains an enduring symbol of modern precision warfare, valued for its reliability, flexibility, and effectiveness across a broad range of missions.